Hello mga ka-Johnny! Welcome back to my YouTube channel. Again, this is Sir Robinson Ipulan, your partner in learning mathematics. Before you proceed in this video, do not forget to click the subscribe button and give me a thumbs up if my video helps you. Okay?
Everyone, so welcome back. So in this video, we will be talking about the intercepts and zeros of rational function, and these are very necessary concept regarding rational function, because once we totally graph rational function, we will be considering this following. Okay, so I do hope that you already watched my previous video. You already have some short quizzes regarding my previous video about rational function, and this time around, I'm expecting that all of you understood the rational function, most especially how it looks like. What are the consideration that we really need when we consider rational function? Okay, so once again, as a review, rational function that is in the form of p of x over q of x, where p and q are functions, and these are polynomial functions, and your q of x shouldn't be equal to 0, because once your q of x or your denominator will become 0 automatically, your rational function will become undefined. So what's the point of solving it if your denominator or our rational function is undefined? Okay, so this time around, let's talk about intercepts and zeros of a function. What are these two things, and how it represent, or how it helps understand rational function more? Okay, so intercepts and zeros of a function. So let's begin with the intercepts. Okay, so the intercepts of rational function. So when you say intercept, we have two things regarding intercept. We have the x-intercept, and we have also the y-intercept. Okay, so how are these thing are connected, or how are this thing works regarding the rational function? You say x and y intercept. These are the parts of the rational function where your rational function touches in the either x and y axis, either x or y axis. Is If you still remember, we have a Cartesian plane. We have the horizontal one, which is the x-axis, and we have we call this one the vertical one, which is in the y-axis. Okay, when I say x-axis, x-intercept rather, this part of the graph touches our x-axis. Okay, so when I say x-intercept, so these are the parts of our x-axis where our graph touches. Okay, so this is an example of x-intercept, and we will be finding in a particular rational function where our rational function touches in the x-intercept. Okay, because these are very necessary. Why are we really need to find this x-intercept? Because it will really help us identify or understand more the work of our a rational function. Okay, again, x-intercept, that is the part of your graph where your graph touches in the x-axis. Okay, so same with the y-intercept. Y-intercept, so obviously it is something to do with the y-axis. Okay, so that is part of your graph where your graph touches the y-axis, and in this graph, as you can observe, particularly here, it touches our y-axis. So basically, this blue one, that is your y-intercept, and this pink one, this one, it touches in the x-axis over here, another here, and a lot more here. So these points, that is your x-intercepts. Okay, those are your x-intercepts. So basically we will find the parts of the graph where your graph touches in x and y axis particularly. Okay, so we will be finding it um, in this video. Okay, so also we have this term called the zeros. Okay, the zeros of our function. When you say zero, zero of the function, this is the solution. Okay, we term it also as the solution of our rational function, because this zeros of a function, it is called zeros of function because it will make your rational functions equal to 0. Okay, so in short, these are the solutions. As you can observe here, we have intercept and zeros of the function. So for zeros of a function, it is similar with the x-intercept. Okay, again, the zeros of a rational function, that is the same with your x-intercept. In short, whatever your x-intercept is or are, automatically those are the zeros of your function. Okay, in short, zeros of the function, these are part of your graph that touches the x-axis. Okay, because in mathematics, all the um, all the parts of the graph that touches the x-axis, that is what you call the x-intercept. At the same time, those are zeros of the function, or in short, this point touches the x-axis. These are the solutions of the graph. In short, when you say solution, it will make your equation equal to 0. Okay, so those are the things that we need to understand. Again, we have intercept, touches x and y axis respectively. We have also zeros of the function, and that is called the solution, and that is similar. Not just similar, it is the same with the x-intercept, ladies and gentlemen. Okay, so these are the things that we need to familiarize. Most especially, this is not only used in rational function. Okay, it is widely used in other function and other graph. Okay, so I want you to familiarize. I want you to put in your mind what are these things all about. Okay, so I prepared here. Begin with wait. Okay, let me begin with example number one. Okay, so for example number one, that is f of x is equal to x plus 4 all over x squared minus 4. Okay, so this is my my example number one. So first thing that you need to ask yourself, is this a rational function? Basically, it is fraction, numerator polynomial, denominator polynomial, and obviously our denominator is not equal to 0. So basically, this is rational. Okay, this is a rational function. So since we already identified that it is rational function, let's try to find the intercepts. Okay, let's try to find the intercepts. Okay, let's begin with x-intercept. Okay, how are we going to find the x-intercept, ladies and gentlemen? To find the x-intercept, so meaning we need to let y is equal to 0. Okay, so again here, in order for you to find the x-intercept, you need to let y is equal to 0. Okay, so meaning you're going to substitute all the y values in the given is equal to 0. Okay, as you can observe, do we have y here? As you can observe, we don't have the same as y, but we believe that way back in our definition of function, f of x is equal to y. So meaning we can able to convert this problem into y is equal to x plus 4 all over x squared minus 4. Okay, so again, f of x, that is basically equal to y because this is the output where your y is the output. Okay, so now in order for us to find the x-intercept, we need to let y is equal to 0, meaning this y here, this one, we need to substitute that one into 0. So it will become 0 is equal to x plus 4 all over x squared minus 4. Okay, you simply let y is equal to 0. Okay, so since you have already y, you let y is equal to 0. So basically, let's try to solve this one. So as you can observe, it is already equation with one variable x. Okay, so as you can observe here, how are we going to solve this one out? So what we're going to do is, as you can observe, our 0 here, we have simply a denominator of 1. Okay, we have a denominator of 1 here because all whole number, we have a denominator of 1. So we have an invisible denominator of 1. So from that, we can cross multiply. We can multiply this one here and also here. Okay, so this is now in the ratio form. Okay, this is now in the ratio form. So basically, we can cross multiply that one. So 0 multiplied, so it will become 0 multiplied to x squared minus 4 is equal to 1 multiplied to x plus 4. Okay, you simply cross multiply, then you simplify. 0 multiply, any number multiplied to 0, it will become 0. And 1 times x, that is x. 1 times 4, that is 4. So that's how we made it. Okay, so let's try to remove it here. So let's simply interchange the position to have a clear, let's put 0 on the other side since they are still equal. So that is x plus 4 is equal to 0. Okay, so after that one is you find the value of x. So since that is x-intercept, you need to find the value of your x. So let's try to transfer positive 4 on the other side. It will become x is equal to -4. Okay, so we already have our x-intercept. So how are we going to name the x-intercept? So we need to name that one as a ordered pair. Okay, so since we believe that the ordered pair is in the form of x and y. Okay, so what is the value of our x here? The value of our x here is -4. What is the value of our y? The value of our y is we let earlier as 0. So meaning our x-intercept is -4 and 0. Okay, that's how we do it. That's how we do that's how we find x-intercept. You simply let your y is equal to 0 and you substitute and you simplify your equation. Okay, you simplify your equation. By that, since we already arrived our x-intercept, that is x is equal to -4. So by naming the x-intercept, we need to name this one as the x-coordinate. Okay, we need to name this one, I'm just sorry, we need to let this one as a coordinate. So meaning ordered pair rather. So x and y, what is your x? That is -4. And what is your y? That is 0. Therefore, let me put it here. So therefore, the x-intercept for this problem is -4 and 0. That's how we do it. Okay, that is our x-intercept. Okay, so so since we are done with the x-intercept, let me okay, there you go. So since we are done with the x-intercept, let's try to solve the y-intercept this time. Y-intercept. Okay, again, this is my x-intercept. Let's find the y-intercept. So if in x-intercept, in solving the x-intercept, we let y is equal to 0. So also same thing with y-intercept. In order for you to find the y-intercept, therefore you let x is equal to 0. So where are you going to refer this one? You are going to refer it one in your equation. What is again my equation? That is f of x is equal to f of x plus 4 all over x squared minus 4. Okay, again, f of x here, that is equal to y. Y is equal to x plus 4 all over x squared minus 4. Again, in order to find the y-intercept, you let x is equal to 0. In short, you are going to substitute all the x's in your equation equal to 0. Okay, so that is y. What is again my x? My x here is 0. You have to substitute plus 4 all over 0 squared minus 4. Okay, and you keep on simplifying. 0 plus 4, that is 4. 0 squared is 0 and -4. Okay, so keep on simplifying. 4 divided by -4, that is -1. Therefore, your y-intercept here is y is equal to -1. Again, I am asking about intercept. Therefore, you are going to give me ordered pair. Same with x-intercept. Okay, again, the ordered pair is in the form of x and y. What is my x here? My x here is we let it 0, so that is 1, 0. And what is my y? Based on our answer, that is -1. Uh, therefore, your y-intercept is 0 and -1, ladies and gentlemen. Okay, that's how we do it. That's how we find um, intercepts of your rational function. Okay, so again, in order to find the x-intercept, you let y is equal to 0 and solve it in the given equation. And for y-intercept, for the y-intercept, that is by substituting it, by letting x is equal to 0 and keep on simplifying. Again, do not forget that in naming x and y-intercept, you have to name this one as an ordered pair. Do not forget that ordered pair is in the form of x and y, where x is the x value and y is the y value, ladies and gentlemen. Okay, so that's how we do it. That's how we find the the x and y intercept. Okay, so let's try to find now the zeros of this function. Okay, the zeros of this function. So as I've told you earlier, that x-intercept is the same as the zeros of the rational function. Okay, They are just the same. Where wait for a while. I am looking. I don't know. Sorry. Okay. So as what I told you earlier that we stated here. Let me rewrite this one again. Okay. Wait. Sorry. Okay. So let me rewrite this one again. Our let me put it here. Wait. Okay, so in our given problem, we stated it here. Our problem is fx equal to x x plus 4. Let me rewrite it again. I'm so sorry. That's very messy. Okay, so this is now x plus 4 all over x squared minus 4, where our x-intercept is that is negative 4 and 0, and the y-intercept that is 0 and negative 1. Okay, so now this time let me inbox this one. There you go. So this time let's find the zeros of this function, meaning the solution of this function. As I stated earlier, I told you that x-intercept and zeros of the function are just the same. So meaning whatever your x-intercept is, therefore that is the zeros of your function. Okay, but it is different now. It is not the way we name x-intercept, because we name x-intercept here as ordered pair. But zeros, we simply get the value of x. What is the value of x here in our x-intercept? Again, your zeros will depend on here. Okay? So will depend your x-intercept because they are just the same. But we name zero based only what is the value of x. What is the value of our x in the x-intercept? Obviously, that is x is equal to negative 4. Therefore, your zero is x is equal to negative 4. Again, you base that one in your x-intercept. Simple as that. Okay, so now, what does it mean by zeros of the function? So what is the use of these zeros of the function? This x is equal to negative 4. It only means that this is the solution of our problem. Okay, what is the problem or the rational function? That is f of x. Okay, there you go. So again, zeros of the function, that is the solution of your rational function. This is my rational function. So this is the solution. What do you mean by solution? So meaning, we can for us to find the value to have x is equal to negative 4, it will make the equation equal to 0. Okay, so meaning it will become, let me rewrite it again. This is now f of x is equal to x plus 4 all over all over x squared minus 4. So meaning once I substitute negative 4 to our equation here, this will make our equation 0. Okay, let's try. So what the value of our x here is negative 4, so it will become f of, what is your x? That is negative 4. So negative 4, so just simply substitute negative 4 plus 4 all over negative 4 squared minus 4. And keep on simplifying. Negative 4 plus 4, that is 0. And negative 4 raised to the power of 2, that is 16 minus 4. That is now 0 over 16 minus 4, that is 12. And 0 divided by 12, that is now 0. Okay, so you can observe here, once we substitute negative 4 or the zeros of the function, which is based on the x-intercept, once we substitute that 1 in our equation or our problem or the given rational function, it will make your rational function equal to 0. In short, negative 4 is the solution of your rational function. That is zeros of the function mean. Okay, so that's how we do it, ladies and gentlemen. Okay, so let's try another problem. Let's try other complicated problem to solve the following. So I have here second problem. Second problem, that is f of x is equal to x squared plus 3x plus 2 all over x plus 3. So this is now our example number 2. Okay, so same thing. So before you find the intercepts and zeros of the function, you have to identify if this given is a rational function. So obviously this is a rational function. given the criteria that I provided to you in my previous video. Okay, so obviously this is a rational function. Now let's find the x-intercept. So x-intercept, let's find the x-intercept. How to find the x-intercept? We let y is equal to 0. And again, f of x here is equal to 0. So it will become now um, x squared plus 3x plus 2 all over x plus 3 is equal to 0. Because again, this is our f of x. We let that one by 0 to find the x-intercept. Okay, so after that one, you can cross multiply. So what will the remaining now? Cross multiply. We have an invisible one here, so it will become x squared plus 3x plus 2 is equal to 3x multiplied to 0. Again, any number multiplied to 0 is equal to 0. Okay, let's continue it here. So as you can observe here, this is now in the power of 2. So meaning, of course, our the factoring skills that we need to develop, that we already learned way back then, is all still applicable in solving this one. As you can observe, this is in the power of 2, meaning we expect two possible values. Okay, we expect two possible values. So again, let me rewrite it again. That is x squared plus 3x plus 2 is equal to 0. So meaning we can factor this one out since that is in the power of 2. So let's factor that one out. So that is x. So let's find the factor of 2. When we add, that is the result of the result is 3. Okay, so that is 2 and 1, both positive. Okay, so we factor this one out. Again, how we did this factoring ways. So you need to find the factors of 2. What are the factors of 2? Only 2, 2 times 1. 2 times 1, 2 and 1. Once you add, the result is in the middle. So meaning 2 and 1. And you can learn a lot of factoring methods in doing it so. Okay, so you can also check some video references on how to do it in a scientific method for you to have an easy way in factoring it. Okay, so I do hope that you still remember how to factor things. Okay, so as you can observe here, I already factored this one out. So after I factor this one out, so we separate this one, equating both side by 0. That is x plus 2 is equal to 0. Once you already factor that one out, each factor you have to equate that one to 0. So this is x plus 1 is equal to 0. Then transfer, that is x equal to negative 2 and x is equal to negative 1. Therefore, what are the x-intercept? The x-intercept, again, how to name the x-intercept? X-intercept is named according to ordered pair, that is x and y. Since you have 2, so meaning you have 2 x-intercepts. It only means that 2 times, or your graph touches 2 times or twice in the x-axis. That's how x-intercept mean. Okay, so therefore, how are we going to name it? This one first is, what is the value of your x here? That is negative 2. What is the value of y? We let y is equal to 0, so that is negative 2 and 0. And what is the other one? So x, what is the value of x? That is negative 1. Again, what is the value of y? Again, we let y here is equal to 0, so that is negative 1 and 0. Therefore, your x-intercepts are negative 2 and 0 and negative 1 and 0. That's how you do it. Okay, so what you call this one, other things about it is that we use other factoring methods. Okay, so we are done with x-intercept. Let's try to find now the y-intercept, ladies and gentlemen. Okay, the y-intercept. Let's try. Let me. Okay, let's find the y-intercept. Okay, how do we find the y-intercept? Same thing. You have to let x is equal to 0 this time. What is my equation? My equation is f of x is equal to x squared plus 3x plus 2 all over x plus 3. Okay, so again, f of x here is equal to y, so that is y is equal to, again, you let all your x's equal to 0. It will become now 0 squared plus 3 times 0 plus 2 all over 0 plus 3. Okay, and you simplify. So that is now y is equal to 0 squared, that is 0 plus 3 times 0, that is 0 plus 2. And 0 plus 3, that is 3. So simplifying, 0 plus 0 plus that is 2 over 3. Therefore, your y here is y is equal to 2 over 3. What is this again? This is your y-intercept. And how we name y-intercept? We name y-intercept as an ordered pair, that is x and y. What is again the x? The x here is we let it by 0, therefore that is 0. And what is the result of y? The result of y is that is 2 over 3. Therefore, in this problem, my x-intercepts are -2 and 0, that we solve it here, as you can observe, and -1 and 0. And my y-intercept is 0 and 2 over 3. Okay, so that's how we do it, ladies and gentlemen. That's how we find the x and the y-intercepts. Okay, so the x and y-intercepts. So we already find x and y-intercept. Let's find this time the what do you call this one? I'm so sorry, wait for a while. There you go. Let's find the zeros of the zeros of this rational function. Again, as I've told you again and again, that zeros of the function, these are the same with x-intercept. Okay, let's find the zeros of this one. What are the x-intercept of our problem earlier? This is the x-intercept, so same thing with that one. So what are the x's in this ordered pair? The x's are -2 and -1. Therefore, these are your x-intercepts. I don't know, these are your zeros of the function. And once you substitute a -2 and 1 differently in our given equation, it will make your equation equal to 0. So I leave it to you. You try to substitute this one in the given problem, and there you can see and there you can observe that it will make your rational function equal to 0, ladies and gentlemen. Okay, so that's how we do it. Okay, so let's have